Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss the topic regarding the vapor pressure. So vapor pressure actually defined as the pressure exerted by a vapor in thermodynamic equilibrium with its condensed phase and at a given temperature in a closed system. So the pressure which is exerted by the vapor in thermodynamic condition or thermodynamic equilibrium will be there, and condensed phase temperature should be looked after, and it should be in the closed system. Okay, so that is known as vapor pressure. It also defined as the pressure exhibited by the vapor which is present above the liquid surface is known as vapor pressure. So how this vapor will be present above the liquid surface, so that we'll discuss here. So for discussing this one, let me consider a closed container. Okay, a closed container. Suppose in this container there is a liquid is present here, and this liquid, let's consider this is water. Okay, so let's consider this liquid as water, and this water need to kept at a temperature of 25 degrees centigrade and atmospheric pressure 1 bar. Okay, now at 25 degree the water cannot be vaporized. Okay, so to vaporize this water we require at least 100 degrees centigrade so that the water can start vaporizing. Okay, so when the water started vaporizing from here, you can say this is in the liquid state. This is in the liquid state, and in this gap also you can see some different air molecules are there. Okay, it's not visible. Let's take another one. Okay, sorry, small will be there because small molecule size. So these are the some molecules are there, air molecules, which is present between this liquid surface and this top layer of this vessel. Okay, yeah, so these are the some air bubble air which is present at this zone. Okay, this also will be give some impact, or it will be give some pressure on this liquid surface, but not that much. Okay, but when the liquid started vaporizing, that means it's going to convert from liquid state to gaseous state. Okay, so here gaseous state will be there. Now here it is liquid stage is there. So when it's going to convert? Now when it started vaporizing. Okay, so when it started vaporizing, this zone will be filled up full of vapor. Okay, and though it is a closed system, so this vapor which is present here, it will create a pressure on the liquid surface. Okay, it will create the pressure on the liquid surface, and that is known as the vapor pressure. Okay, that is known as the vapor pressure. So how it happens actually? So let's try to understand this concept. So when let's say before heating or before vaporizing, normal water is there, and here it is air is there. Okay, so it won't convert from liquid state to gaseous state unless it will reach the 100 degrees centigrade. Okay, now when you started vaporizing, there is a change in temperature. So you can see the liquid which is present, it will give a push to the air. Okay, so that means the water molecules will be pushed the air molecules. Okay, so when there is a pushing will be there, there is a disturbance in this, then there is a pressure will be created here. Okay, that means the water molecules which is present here, that is going to give a push to the air molecules. That means it's giving some pressure to that. So in this zone also the pressure will be created. Okay, so that in one region. And second thing is, when this vaporization started, the air molecules started, this air molecules started moving here and there. So due to this movement, there is a collision between the air molecules also will be there, and this collision also makes a impact. That means a pressure creation will be there. So that pressure will be give an impact on the surface of this liquid, and that is known as the vapor pressure. Okay, and thing is that we need to consider, as I told you, first things we need to see the thermodynamic equilibrium condition. Okay, and it should be taken in a closed system. Okay, and here one more term also there, that is boiling. Okay, so the boiling will be done, you can say, when the vapor pressure will be equal to the atmospheric pressure. Okay, when the vapor pressure will be equal to the, we can say, P atmospheric equal to, vapor pressure, then our boiling will be takes place. That is one term. Okay, so here you can see one diagram I have given, the liquid part, and this here it is converted to vapor, gases conversion is there, and after converting this one, these vapors, these molecules is moving here and there is a collision between all these molecules, air molecules, and that will be give a pressure on this surface. So that is known as the vapor pressure. Okay, this is one point. And second thing what I want to say, there is a relation between this temperature and the vapor pressure, you can see here. Okay, as the temperature increasing, okay, the vapor pressure also increases. Okay, so there is a relation between them. Once temperature increases, the vapor pressure also increases. Okay, that is one point. Because we know that the boiling point of the temperature is 100 degrees centigrade, and but that is also one reason is there, that is you need to indicate that it should be at 1 bar pressure. That means P atmospheric, pressure atmospheric at 1 bar pressure. If pressure changes, then the boiling temperature of the liquid also going to change. And here the diagram you can see at 1 bar pressure, the normal boiling point is there. Okay, it given the normal. As the temperature increases, this vapor pressure also increases. As I told you, that means the temperature increases, and you can say the vapor pressure also increases. So I hope you understood the concept of this vapor pressure. If you are having any kind of doubt regarding this, you can give a comment on the comment box. Thank you all.